paradox of Plato's cave. The people of Plato's cave don't think they're in a cave. How would you know unless you'd left the cave? The people of the cave don't want to know about the outside. They don't know they're in a cave. But if you were to tell them they're in a cave, they might kill you. After all, who wants to think of themselves as stuck in a cave? With nothing but the shadows of reality, provided to us by our media. Lots of strange things happen in the cave, like automatic debt slavery, the invisible chains that bind us to the wall of the cave, and all for using a currency designed to transfer wealth from you to the provider of that currency. And all along, it's you that gives that currency value via your birth certificate that pledges you as an asset to pay back your country's debt, so you can be borrowed against and invested with. So what is reality? Is there a wizard pulling the strings behind a curtain? If reality is sanity, we need facts, not theories. We need to look into physics, because math doesn't lie. So I want to ask one simple question so we can identify the lie, and then we have a constant. How does a rocket have motion in a vacuum? The last moon landing claimed by NASA was in 1976. Since then they have claimed various other space expeditions. They have even claimed to have put a robot on Mars. The cost to the taxpayer of all the countries that fund NASA is phenomenal. NASA also claims to have lost all the technology and information that got them to the moon in 1976. So how did they get to Mars? Sir Isaac Newton was a British physicist born in 1643. And one of his greatest discoveries was his 3 laws of motion, one for each dimension. Let's have a look at his 3rd law. The 3rd law of motion states that for every action there's an equal and opposite reaction. So what does he mean by that? Well, it's like a stone in a lake, where the ripples go in every direction. If you look at one particular ripple, there's an opposite ripple going the other way. And the stone hitting the lake is the action. It's like an explosion. So, this is the law you would use if you wanted to make something move forward. For example, a car, a ship, a plane, or a rocket. So what is motion? Let's assume that it's us that wants to move. And we have to move relative to something else. If there's nothing else there, there's no motion. That something else will have mass, and so it will exert gravity. Now you being a mass will fall towards the greater mass. If you don't want to hit that mass, you need to convert the force of gravity into forward motion in order to combat gravity. So gravity is the thing we need to move relative to. Motion is always going in the opposite direction from gravity. If you're going towards gravity, you're falling. So motion is like anti-gravity. It's always moving in the opposite direction to gravity. And to have motion, you need an action. So what is action? As the law states, for every action there's an equal and opposite reaction. If nothing happens, nothing reacts. So an action has to be something happening. And the only thing that can really happen is an expanding or a contracting. An explosion is an action. A spring pushing is an action. What is a reaction? We want motion. So motion is the reaction, or motion of an object. We want that to be us, so motion of mass. What is the opposite reaction? There has to be another mass moving away from the mass we want to propel. And this is the mass we're moving relative to. So if we want to propel our rocket, we need to move it relative to the Earth. And that's the total Earth, the total mass of the Earth, including the atmosphere. What does the third law mean? It means it's a law of physics, and there's 3 parts to it. So you have the action, you have the reaction, and then you have the opposite reaction. 3 parts. And if one of these parts is missing, the law isn't going to work. And you won't have motion. Let's take a spring and 2 boxes of equal mass deep into space and well away from gravity. If we put the spring between the 2 boxes and push the boxes together so the spring is totally compressed between the 2 boxes, and then let go of the boxes are going to move apart at equal speeds. We can mathematically represent this as E for energy or action squared to show it's expanding. We can call one box X and we can call the other box Y, and we can use times to show that the 2 boxes are moving apart at constant speed. So it reads X times E squared times Y. What would happen if we doubled the mass of Y? X would move away from the spring at double the speed of Y. So you can think of yourself or the rocket as X and the mass of the planet as Y. So what just happened? We had our action, or our explosion with the spring expanding, and the 2 boxes with the 2 reactions, one reaction one way and the opposite reaction the other way. This is how a gun works. You have an explosion between 2 boxes. One box is the bullet and the other box is the gun. When the gunpowder explodes, which is actually expanding gases, and that pushes the bullet out of the barrel of the gun, because it's the only place the gas can escape. So this is a reaction to the explosion, and the opposite reaction is the recoil of the gun, which moves in the opposite direction from the bullet. Now let's go back down to Earth and take a look at how we actually move. So now we're back in gravity, we have to include that, and we want to carry our spring with us, which means we take the spring and attach it to one of the masses, the mass that we want to move, which is X. If we were just a straight stick or a pole, we wouldn't have any motion, we wouldn't be able to move. It wouldn't matter how much you wanted to, but we're not a straight stick. We have a hinge. So we're a stick with a hinge. One unit, or a body with a foot. The foot is the spring, and it's attached to the body, and it can be attached to the body via a hinge. So the foot is the spring is attached to X via a hinge, or a pivotal point, and that pivotal point is where you convert gravity into forward motion. On the other side of your foot, where your foot meets the ground, you could call this another hinge, which means you can lever one mass against the mass you want to move relative to. Now we grip the mass we want to move along with the force of friction or resistance, and this is what connects our foot to the earth we want to walk along. So our representation now looks like this. We have X and Y And these are the two things we want to move relative to each other. X is the rocket, U, the bike, the car, the ship, and Y is the mass that you want to move relative to, the planet Earth. Now we want to connect the thing we want to move forward to the thrust. So the thing we want to move forward is me, because I'm walking. The thrust is my foot, and they're connected via the hinge. So it's X times E squared. E for energy, it's squared because it's expanding. And the times represents the point that gravity is converted into motion. So that is the axle or the hinge or my ankle. And we can put those in brackets just to show that they're connected. And it's one unit. So between my foot and the floor, we have the force of friction and resistance. And we also have friction and resistance in front of me. I am resisted by the atmosphere. And these two things are relevant to each other. So we can times either way. Now, behind me, or the rocket, after the thrust and after the friction, you have the actual mass of the object you want to head away from, which in this case is planet Earth, or the ground, or Y. The thing that's causing the gravity that you want to move away from. On the other side, in front of the rocket, we have gravity after the friction. And that is relative to the mass, so we can times that too. And the whole equation is contained within space-time, and these two things are also relative to each other, so we can have space at one end of the equation and time at the other end of the equation, and to show they're relevant, times. So let's take a look at a car, and again we want to move the car relative to the planet. The car is attached to the spring, or the thrust, via a hinge, or a pivotal point, which is the axle. And because of that axle, we can actually bend the chassis now to 90 degrees from the direction of gravity. So if gravity is pointing straight out to space, we can now travel at 90 degrees from that and move horizontally to the force that is exerting the gravity. In our case, the planet. So back to the car. So the wheel is the spring. The spring is attached to the car via the axle. On the other side of the wheel is another pivotal point where the wheel connects to the road, or the mass you want to move relative to. In front of the car we have friction and resistance, and we have friction and resistance between the tyre of the car and the road. And the axle is the point you convert gravity into motion. And of course it takes time and space to go anywhere. So now of course we need to define the power of our explosion, or E. But we can call that velocity, and that is directly relevant to motion. So the more velocity of the explosion, or the power of our spring, the faster our acceleration. So if we have another look at our representation, if our rocket weighed 750 kilos, it would take 750 kilos of velocity thrust to reach 0 G, which is only going to get a rocket off the ground. But if we add another 750 kilos, now we're going to accelerate to 1 G. And of course a rocket needs to continuously keep accelerating, otherwise it's going to go out of control. So the velocity of our explosion has to be exponential in order to keep a constant velocity of acceleration for a rocket, just to keep it on course. So let's move into a liquid mass and take a look at a ship. So you have the ship, you have a hinge, you have a propeller, and you have a mass to move through. The point the propeller connects with the mass there's resistance. And after the propeller, there's a column of fast-moving water being forced into still water that's not moving. As water's not compressible, that water will push back against this column, and in turn back up against the propeller and against the axle, and will give the ship forward motion. So this column of water moving away from the propeller is the spring. The propeller itself has an axle, and that's the point that's converting gravity into forward motion. Let's reduce the mass of the thing we want to travel through even more and go into air. And of course a plane engine works exactly the same way as a ship. There's a turbine in the engine that's revolving on an axle. This turbine is creating a column of air behind the engine, and this is the spring, action or thrust. One end of that column of air meets the atmosphere, and the other end of that column of air meets the turbine. So you have high pressure air created by the engine of the plane being blasted into low pressure air, which will cause it to expand and push back up against the engine and back against the atmosphere. So the column of air is pushing at both ends, like a spring. So when you look at a stationary rocket, what you really have is just a pole. There's no action and it's not moving. So let's take a look at a rocket when it's flying in the atmosphere. So we have a pole and we have a controlled explosion coming out of the back of the rocket. It's fed by the fuel from the rocket. And the hinge is the point where the fire meets the back of the rocket. So you could say that the rocket and the fire coming out of the back are one unit, divided by a hinge. The rocket and the fire are connected via the fuel supply. So this controlled explosion is actually expanding gases, expanding because of the vast temperatures. And it's expanding in all directions. So it's pushing one way against the rocket and the other way away from the rocket and against the atmosphere. The point the fire meets the atmosphere, there's a temperature exchange, and the fire will heat the gases of the atmosphere, so they expand and equally push back against the fire of the rocket. And this is how the rocket gains enough resistance to grip the atmosphere and provide forward thrust. So when you look at a rocket, it's quite clear where the action is, or the spring. The actual rocket, the metal part, nothing's moving and there's no action. Clearly the action is the explosion coming out of the back of the rocket, and this is exactly the same as a spring. So we have X, we have the action, which is the fire, and we have Y, which is the atmosphere. So what happens when you take Y away and go into a vacuum? Remember, there's three parts to this law. For every action, there's an equal and opposite reaction. So what's the opposite reaction to the rocket? Now there's no atmosphere to move away from it. What would happen if we went back up into space with our two boxes and our spring? Except this time, we only had one box. It's not going to matter how big or small that box was, or how big or small that spring was. What's going to happen? Nothing's going to happen. Except this time we have gravity. There's no resistance or friction, but there's still gravity. And the minute you lose thrust, gravity will pull you back towards it with the same force it took to get away from it in the first place. What would happen if you were swimming and someone took away the sea? NASA's explanation for this is exactly the same as saying, if you grab yourself by the hair and pull, you'll be able to lift yourself off the floor. But what would really happen? Well, Newton's law demands that there's 3 parts. So if I pulled hard enough, I would actually rip my head off, and then I'd have motion. What would happen if I took the second reactive mass away from our law? The rocket would demand 3 parts to the law, so it would rip itself in half. Either that, or it'd have no motion. Now some people say that the exhaust gases from the fire coming out of the back of the rocket are the thing that provides the mass to our Y in our law. But that mass is moving away from the fire as fast as the fire is moving. So it'd be like trying to walk on a road that was dropping away from you. And the vacuum of space would immediately take away any atmosphere. And that exhaust gas is an atmosphere. And so is the controlled explosion coming out of the back of the rocket. What happens as a rocket gains altitude? Gas is compressible, and the atmosphere is a gas. So the mass and the density will exponentially decrease because of the pressure drop. So the rocket would have to exponentially increase thrust in order to maintain a constant speed. So what happens as you approach the vacuum? The infinite vacuum. Infinite thrust. Infinite thrust with an infinite fuel supply that had infinite mass. So this is a paradox. And the only way to get a rocket to work in space is to give space an atmosphere. So there you have it. The physics hoax, or one of them. No need to even bother talking about the outrageous amount of radiation in space. They did teach us Newton's third law at school. But then they stuck rocket science onto the end of it, which is a contradiction of Newton's third law and a paradox. So Newton's third law is a law of physics. Rocket science isn't. And just because NASA or Hollywood, which is what they really are, or their TV personalities or their fake pseudoscientists say it is, doesn't make it so. So why? Well, they've certainly interfered with the majority of the world's perception of reality. Most of the world now thinks that reality is a conspiracy theory, and that truth is hate speech. So who? Well, who would have the power to do this? Well, money is power. And he who creates the money has ultimate power. So if you were part of the Zionist banking mafia running things through the Masons, there's 2 things you can do. You can do like the Bolsheviks did in Russia, and that's just kill off all the intellectuals. Or you can indoctrinate them from a young age, so they continually fight about what reality is. And in the meantime, you can fill their mind with fantasies about space travel and charge them a monumental amount of money for the privilege. So how is this group utilizing their power? It's a secret, passed down through secret societies. So my fellow cave dwellers, might be time to think about getting out of the cave.